Welcome to our third episode over the trigonometric identities. So here I will use the hexagon to derive the formulas. So from the previous episode, we know that tan is given by sine over cos, then cot opposite to tan, then all the c's to the opposite, to the right side I mean. So it is cosecant, then the secant. So assume I'm placing there a 1. So using arrows, so they are facing 1. If you take the sine of the angle, sine theta, then you multiply by the cosecant, the opposite now identity, the result is 1. Same, the tan, that angle multiplied by the opposite identity, which is cotangent, the result is 1. Same to here, by the opposite identity, then the result is 1. So if you take an identity, then you multiply by the opposite identity, then it gives you a 1. Complementary angles. So complementary angles. So two angles are said to be in complementary if their sum equals to 90. So sum of two angles gives you 90, so they are said to be complementary. So from our knowledge, we know that tan is given by sine over cos, tan opposite with cot, then all the c's the right side, remaining with sec. So here, let me use the arrows. First arrow, then the second arrow from here, then the third one. So the sine of theta is given by the cos of 90 degrees minus the angle. Then here, this arrow, the tan of theta is given by the cotangent of 90 degrees minus the very angle. Then last one, the secant of an angle theta is given by the cosecant of 90 degrees minus theta. So let's assume our arrow is changing to this direction, this one, and that direction. So from this, the cosine, so you take where the arrow is coming from. So cosine of an angle theta is given by the sine of 90 degrees minus theta. Then the cotangent of theta is given by the tan of 90 minus the angle. Lastly, the cosecant of theta is given by the secant of 90 degrees minus theta. Thank you for watching the video.